Welcome back to the Awesome Agents podcast. So, Maya, Alibaba just dropped Qwen3.5, and the numbers on this one are kind of wild.
Yeah, this is a big release. 307 billion total parameters, but only 17 billion active per token. And it is open weight under Apache 2.0.
Okay, so let me make sure I understand this. It is a massive model, but most of it is asleep at any given moment.
Exactly. That is the mixture of experts approach. You have 512 experts, but only 10 get routed per token, plus one shared expert that is always on.
And they're saying it matches GPT 5.2 and Claude 4.5 Opus on most benchmarks?
On about 80% of their evaluated tasks, yeah. But let me be specific about where it wins and where it does not.
Please, because I always want to look past the headline claims.
So on instruction following, it clearly leads. It beat GPT 5.2 by almost 10 points on multi-challenge. That is a big gap.
That is huge. What about coding and math?
That is where it falls behind. GPT 5.2 still leads on AMI Bench. Claude 4.5 leads on SWE Bench. Quinn's team was honest about that.
I appreciate that, actually, the honesty. So, what is the real standout then?
Vision. And this is where it gets really interesting technically. Qwen 3.5 is natively multimodal, early fusion from the ground up.
Meaning images and video are not bolted on after training?
Right. Previous Qwen 3 shipped text and vision as separate model lines. This time it is all one model. The result is a 20-point lead over Claude on spatial intelligence.
20 points. That is not a rounding error.
Not even close, and 12 points ahead on OCR. If your use case involves understanding documents or images, this model is currently best in class.
Okay, so the other thing that caught my eye is this hybrid attention architecture. Can you break that down?
So, this is actually the most interesting technical detail. They're using two types of attention in a 3-to-1 ratio.
Two types. I thought attention was attention.
Not anymore. 3 out of every 4 blocks use something called gated delta net, which is a linear attention variant. It scales subquadratically.
So it gets cheaper as the context gets longer.
Much cheaper. Then every fourth block uses traditional full softmax attention, which gives the model periodic access to exact attention.
Like a reality check every few layers.
That is actually a great way to think about it. And the speed gains are dramatic. 8x faster at 32K context, 19x faster at 256K.
That is what makes a 400 billion parameter model actually servable.
Exactly. And there is a great quote from Hugging Face's Emlabon saying, "Nobody agrees on attention anymore. DeepSeek uses MLA, Qwen uses DeltaNet. The field is diverging."
So we might be entering a period where different architectures are good at different things.
I think so. And that is honestly more exciting than everyone converging on the same design.
Now, practically speaking, can anyone actually run this thing?
BF16 needs about 800 gigs of VRAM, so that is like 10 H100s. But the FP8 Quant cuts that in half, and community GGUF Quants can fit on a 256 gig Mac.
A Mac that is still expensive hardware, but it is not a data center.
Right, and smaller variants, a 9B and a 35B, have been spotted in pre release. Those will bring this architecture to normal developer hardware.
So the big picture here, an open weight model with an Apache 2.0 license that genuinely competes with the best proprietary models on most tasks.
And is natively multimodal. That combination of open, multimodal, and frontier competitive, no other model does all three right now.
That is a good place to land. Thanks for walking us through it, Maya. Listeners, links to the model and benchmarks are in the show notes.
And keep an eye on those smaller variants. That is where this architecture will really get tested in the real world.
Until next time, I am Alex Rivera. Thanks for listening to the Awesome Agents podcast.